Okay, in this video, we will finish off remainder factor theorem. Then we'll do solving of cubic equations as well as partial fractions. Okay. Alright, so if you were to divide these by these, this one is just a recap. Okay, the dividend is this fella, divisor is this fella, the quotient you will get it later. Okay, that's the whole thing on the top for long division, and then the bottom for the remainder. Okay, but there is another way to write this, and that is this. Okay, in short form. Okay, I just show you what I try to tell you here. Okay, now if x equals to 2, this whole thing would disappear. Then you don't have to bother about the qx already. Now all this we have done in class before, so I won't belabor the point. In fact, all the slides here, we have actually done it in class, not going through this, but I elaborated on the whiteboard and all. Okay, so once this is gone, the only unknown is this. And that's why your F2 is your remainder. Okay? Yeah, so this is the remainder theorem, just a reiteration of what we have done the previous time. Okay, so this part we have done also. Okay, now we are going to do the quick check. You can go and do your quick check if you want. Okay, when divided by this, when divided by this, when divided by this, and these are the answers. Now, find k if this one leaves a remainder when divided by this. Now, firstly, as mentioned before, this polynomial has no name, so you've got to give it a name first. Okay, you can call it h, f, g, whatever you want to call it. Okay, then the important thing is what to substitute in, so you equate this to 0. Why? Because you want to make this whole thing 0. That's why you equate it to 0 to find out what x value to sub in. And once you sub in, you can find the answer. Okay, this is the value of k. Okay, and this is not the so-called the hx. Okay, it's not the hx, but it is the h2. That means when you sub in the x equals to 2 inside this polynomial, right, then you will get h 2 equals to a certain value. Okay, then that will be your k equals to 8. Then down here, right, again you have to give it a name first. Okay, and then read carefully. It leaves a remainder of this, so this is one set of equation that you can come up with. So p 2 is 27, and from here you can get one set of equation, this one. From here you can get another set. Okay, then you solve them simultaneously and you get this answer. Alright, okay, then you are supposed to find, this is calculate, find the remainder when the polynomial is divided by x minus 1. So right now you already know these two values, you just sub in and you get the answer. So this is your remainder. Okay, it has the same remainder when divided by this or this. Okay, so what you do is, this one, you give it a name first. Yeah, I think they didn't show you the working, but never mind, I just roughly tell you. You can call this f, give it a name first. Okay, then you sub in 1. That will be what you write on the left side of the equation. You write equal, then you sub in minus 2, sub in minus 2 here. That will be what you write on the right. Then you manipulate, right? Manipulate, make a minus b the subject on the left. You'll find that the right hand side, the value is 6. Okay, so that's how you do the question because it's not shown, the working not shown here. Okay, factor theorem. What is factor theorem? Factor theorem is something like remainder theorem lah. If your remainder is 0 when divided by 7, right? For this number 1022, then of course 7 is a factor. Or you can say it is exactly divisible by 7. This is what you learn in primary school. Okay, now after this, you can make this conclusion for the factor theorem. Alright, now bear in mind, as I want to tell you again, this need not be coefficient 1, could be 2x minus 3, 2x plus 4, 3x minus 1, whatever, okay? Now whether this one is a factor, you need to equate this to 0, find out what's the x value to sub in, and if the remainder is 0, then this is a factor, okay? But of course you need to give it a name first, and then you do what I just told you. Okay, so it is 0, which means that it is a factor. That's it. Okay, so in your WA2, the reason why some of you didn't get full marks is because you didn't show this step for the polynomial question. Okay, so as I mentioned in class many times, this step must be present. Okay, and you cannot just say, oh, f minus 1 equals 0. You see every single question that I've done for you in class, okay, and in the discussion, I showed this step. So you must show this step. Something like your quadratic equation, you must show the substitution. Now, this is another question. Again, you got to give it a name. Okay, you see, always give it a name. And it's exactly divisible by this. Now, this part here, you got to split this into two linear equations. You know why you got to do that? Because it can be, number one, because it can be factorized. Number two, right, there are two unknowns. So when you have two unknowns, you definitely need two equations. So first step is to factorize this, and you'll find that it is made up of two factors, 1, 2. And it means that, okay, this is a factor. That means when you equate this to 0, that's x equals to minus 1, and then x equals to 3, right? So you can get one equation, and then this one can get another equation. Solve them simultaneously, and then you'll get this. Okay, this other question is something like your WA. Okay, and we have done many of these in the worksheet that we have done in class. You basically have two unknowns, A and B. So you will need two equations. The first equation, this one you must read carefully. Factor of this, that means your remainder is 0. So call it a name first. Then you f minus 2, that should be 0. Okay. Then you f 1, that should be 6. That's it. Solve them simultaneously. That's it. Okay. Then you do a quick check. Okay, maybe you want to do a quick check. Don't use long division. Use the factor theorem. Alright. Then okay, this ding ding dong dong. That's it for this. But I'm not done yet. I just quickly finish off this topic. Okay, this one doesn't concern us. Okay, then check whether this one no, this one we're done already. Okay, now we will be doing cubic polynomials. That means how to solve polynomials of degree 3. Okay, they focus on degree 3. They're very reasonable. They will not make you do too much. Okay, so these are the things you need to know. Okay, so this we just discussed today. Okay, and you're supposed to memorize. So as I mentioned to you, this one follow, so same, opposite, then the rest all positive. Okay, same, then opposite sign, so SOAP lah, SOAP. Okay, but it's actually, I think, a very easy format to remember. So firstly, you have to write it as I actually don't really like this. Okay, because normally when I teach you, I want you to put the bracket. Okay, so that you know what to put here, what to put here. You put the things that are inside the bracket here. Okay, then you square this. That's why it's 49. Square. Okay, maybe I just do a fast one. Try to write here. Can write, okay. So please put brackets, then whatever is in the bracket comes here. Okay? And then you square this, you square this. Then is this times this. That's it. There's no 2. You see, it's 7 times A, 7 times A. Then the sign, opposite sign. If I'm plus, you're minus. If I'm minus, you're plus. That's it. It's a very simple factorization kind of technique. Okay, so next, this is what I like. You must have brackets. Okay, then whatever is here, put here. Because it's plus, you follow, and whatever is here, put here. So it looks very complicated, but actually it's not complicated. Okay, then you square this, 16, square this, square this. Okay, when you square these, it's not t square plus 9. Okay, I need to keep on repeating this. Maybe I need to repeat it for a year. Then you will get it. Okay, so it's actually this. Okay, then this is just this 4t times this, you see. And why is it minus? Because the sign must be opposite from this one. So it's sign, same sign here, same, opposite, then all positive. The rest are all positive. Okay, now next one. The next step simply is algebraic manipulation. Combine what you can combine the like terms. This one when you expand, and this one when you expand, you can combine into these. Now when you expand this, it's not t square plus 9. Okay, it's not. It is t square plus 9, then plus this times 2. Okay, so note the difference between these and the difference of cubes. This one don't have times 2 for difference of cubes, whereas this one have. Okay, now same thing, same old story, but as I mentioned, always talk first, take out common factor. You're going to refer to my previous videos. I mentioned about this. Then remember I say put the square bracket, then inside put the round brackets. Okay, then you get this. So you double check, see whether you can get the answer or not. Very simple one. You square this, get this. You square this, get this. Then this, whatever is inside the bracket, times this. That's why it's 3PQR. Don't need to times 2. In fact, cannot times 2. Then this one, same sign, opposite sign. That's it. Same. Okay, you go and see whether you can do or not. Okay, let me just show you one more step here. You always need to find out whether you can write it as something cube minus something cube. You see, in this case, there's no take out common factor, right? There's no common factor to take out, so no need this step. Straight away, you jump to this step, and then you do what you need to do. How about this? Okay, this one. You will find that if you were to do it the other way, this is actually an easier way to do it. Okay, but if you try on your own, some of you may do it this way. You'll find that it is more tedious. Okay, I leave this to you to try. If you have any difficulty, you can ask me. Okay, how to factorize cubic polynomials. So this is just a revision of how you do factorization of quadratic. You simply factorize and then you solve, right? So the answers are known as the roots or the solution of the equation. Okay, cubic, just now the quadratic 2 answers, right? 2 roots. Cubic, you will have 3 roots. Okay, so that's the whole idea. You need to find the 3 roots. But before you can solve, you need to factorize. So what you need to do is to find the factor theorem. So this is actually question 1 of your WA. Alright, of course we are not going to do all this. Don't go and be silly and go and try all this. No, you immediately use calculator and plug in the correct answer. Okay, which is F2. The calculator will tell you 2 is one of the answer. And then you go and ding dong dong. Okay, and you see, actually there's no need to do all this long tedious thing, because as I already told you, actually all this no need. You straight away come to this step. Don't waste time doing this. You attack the 2 highest power. What number times 1 will give you 2? Of course it must be a 2 here. Okay, then what number? That means now you assume you don't know this C. What number times minus 2 will give you this? Actually, very simple. You just take minus 6 divided by minus 2, you get 3. So you wrote plus 3 here. So you can use the calculator to help you. And after this, you have to compare coefficient. You can choose either compare x squared or x. And this is what you get. Okay? We've done many of this in class. And after that, you got to factorize. Once you have fully factorized, now this is the step that many of you are very sloppy when you do in class the working. You will just say, oh, x equals 2 or x equals minus half or x equals to minus 3. Now, this is not even an equation. You are just solving. You see, there's no equal sign, equals 0, don't have. So you cannot just straight away write this step. You actually have to, let me see whether they write or not. You see, you actually have to write this and then you can solve it. Okay, so you have to be more mathematically accurate when you do working like this. Okay, next let us try and do one more. You can go and try on your own, then after that come and check answer. But firstly, no, sorry, this was the same question just now, right? They're just trying to tell you that when you solve this, you get this. Okay? Now you cannot like them like that straight away come here. Cannot. You got to show all the factor theorem lah, whatever. Okay, you cannot just press calculator and then get that one. Okay. How about if you don't want to use long division, then you can use, many of you are doing this because you love to do long division. Okay, I mean that's fine. Yeah, you see, you get the same result as what I have gotten just now through the inspection compare coefficient method. Okay. Okay, this slide, they are just trying to tell you that this one, okay, is a linear factor, whereas, so when you have a linear factor, right, this side will be quadratic because when you combine them together, it has to be power 3. But if it's a quadratic divisor here, then this has to be linear because when you combine them together, it has to be cubic. Okay, let's do another one. You can try on your own. Again, must give it a name, and then you ding dong dong go and do your stuff. You see, these must be present, so you cannot omit this. I hope you don't spend too much time doing all this. It's a waste of time. Okay, you straight away come to this step. Okay, then you compare, and then you will get the answer. Alright, that's it. Okay, so these we've done many times in class also, at the video also. Insert form means your answer, you see, one of them is not a very nice answer that you can factorize. Okay, go and check it out whether you can do or not. Then this one is the same as what we have done in class. Then this one show that it has only one root. Now in order to show, right, you got to make the right hand side 0 first. Oh, it never show. Okay, then you go and try lah. You cannot do it, ask me. Okay, then there's a quick check. You can go and quick check yourself and then see whether you can get this answer or not. Okay, this one you can try if you want. Okay, that's it for this particular one. I'm going to do one last one now, which is the, what do you call that, partial fractions, and that's it for this particular video. Okay, partial fraction, these are the objectives. You see, there are, whenever you can do long division, right, you do long division, because when you can do long division, that means it's improper. When you cannot, that means it's a proper fraction. What do I mean? Let's take a look. Okay, this part here, they are just showing you, when you, like in Sec 2, this one I've done before in class also. When you combine these, you get this. So now the reverse is to find the partial fraction. So these are what we call the partial fractions. Okay, we've done this in class before already, the explanation. Okay, so this is called partial fraction. Alright, the reverse of combining into a single fraction. Now let's look at proper fraction first, where the degree of the denominator is less than the degree of the so the degree of the numerator is less than the degree of the denominator. Okay, examples are like this. That means this power is less than the combined power of the denominator. You see, it's less. How about the improper? Improper is same or more than. Okay, so let's take a look. Can you see this power 3? And then the denominator you combine together, right? This is power 3 also. So this one is considered improper because you can do long division. As long as you can do long division, you want x squared, right? You can do, as long as you can do long division, it's considered improper fraction. Okay, so let's take a look at proper fraction first. This is what you have done in sec 1, sec 2. So we're going to do the reverse. Okay, we've done this before. I will just run through. Okay, this one we are trying to get from here to here. So lower sec is from here to here. Upper sec is here to here. Okay. So remember I told you that there are 3 cases, right? The first case is linear. This one. When it's this one, right, the numerator would be a number. You can call it A, B, or C, or whatever. Then when it's something that cannot be factorized, as we mentioned before, irreducible. The word that I used in class was irreducible. That means cannot be factorized. Quadratic. Why quadratic? Quadratic because it's quadratic lah. Then factor. Okay, so when it's that case, you must have ax plus b. So let's take a look here. Okay. Yeah, then you, this one none of our business. None of our business. When it's repeated root, remember I said repeated root, then you must have 1 power 1 and it's a number power 2. Okay, so that's for repeated root. And you notice that it's a linear repeated root. That means it's not square. This is not square. Okay. So this is a summary for partial fraction. Okay, what you should be writing them. Now you can try, you can pause the video and try these. What you should express them as. Okay, so this one very simple, is all linear, so put all A and B. This one repeated, so power 1 power 2, as in power 1 time power 2 time. That's what I mean. Then the number is a number on top, no x at all. This one can factorize, it's linear. This one is repeated linear factor, that's why it's like that. This one is like that. That's it. So the one that cannot be factorized, you have to put bx plus c or something x plus another constant. Okay. Yeah, then the same old story. We've done this before. So you can see you multiply throughout by, this is what I told you. Okay, don't use any other method. Use this method, multiply throughout by what you have here. Don't think of it as cross multiply, don't. Okay, because when we set certain questions and you think that way, then you will have problems. Okay, so this is what we have. That's the final answer. You can go and try. Same here. You can go and try. Okay. Okay, now don't be afraid when you get a fraction answer for the constant. Okay, don't be afraid. Later I show you how it's. We have done all this before lah. Okay, then you go and get some of you careless one you won't be able to get. Okay, but basically when you put it inside here, take a look. how to remove the denominator. Notice that the denominator, they're all 3, right? So what it can do is you times 3 here, this denominator will disappear, but you cannot just times 3 at the numerator like that, cannot. I'm only multiplying 3 to this, okay? You got to times 3 at the denominator also, so that effectively you're multiplying this whole thing by 1. Same story here, I times 3 here, I must times 3 here. That's how you end up with the next step, like that. Okay, because this will cancel out. Bye bye, gone. This will cancel out. Then you end up with this. This you should actually throw down and then simplest form. Okay? Can you see that? That's what we call simplest form. Okay, just quick check. Express each one in partial fraction, okay? Just go and do it this way. Yeah, so you just go and try it out if you want. This one, partial fraction. Now, can you see that this is linear? So the numerator should be just a. This one, you cannot factorize it, so it has to be bx plus c. Okay, so you go and try. You go and try now. Improper. Now we talk about improper right now. When it's improper, improper means you can actually do long division. So in this case, can you see that when you combine these two, it's x squared. You can actually do long division. So long division, I think most of you have no problem. You go and do long division, and then you will end up with this. Okay, so let me just explain. This one we're done in class before, so you put here. The remainder, you put it over your this divisor. Okay, so that's it. Why is it like that? Because this times this is actually your that thing there, okay? But the remainder is x minus 5. Then now we go and then these are all the examples I gave in class also. And now your focus should be on this. When you do partial fraction, right, it's on this part only, because this is nothing to do with the partial fraction that you're trying to find. Okay, then you go and do this, and the same old story, multiply throughout by x plus 3, x minus 1. Then the same old story continues. Ding ding dong dong. Then remember to put back, and remember the 4x. Yeah, this one. So this should be your final answer. Okay. Alternative method is this one I taught you before, but some of you don't really understand. Okay, so you can actually do it this way. Okay, and then you compare the coefficients. Alright. Okay, this one you can forget about it. If you want, you can do lah. If you want, you can do. It's all in your book. Okay, that's it.